Hello everyone. So who's here to learn something about vehicle abstraction? Okay, you reached the right room. Perfect. Because that will be my topic for the next couple of minutes. Let's see how many we get into. And the caveat here is also, it will be mostly based on open source technologies, and you will also see how this interacts with the Android ecosystem. Because maybe a few words from my side, I'm not the typical seasoned Android developer doing senior super expert doing native apps for 7 years. I'm more coming from the automotive side, realizing something like that we call a software-defined vehicle, or in short, SDV. But in the end of the day, also the story is make life of developers developing applications for the car or the software-defined vehicle as easy and as fun as possible. So one quite naive approach would be to take just all the cool IT stacks that we have, Android, Linux, Docker, Angular, maybe Kubernetes, and just cram it into a car. I mean, if we do this, we get a software-defined vehicle. At least we get software in the car. But is this a good idea? Because what we did achieve then is you can easily deploy an app there. You can maybe also deploy WordPress, or if you fancy, you also deploy Doom. But the bet is, especially in a car, you should get security and also especially safety. You should get it right. Because, for instance, if you look at some Android apps in the car so far, you're really restricted with the access to the signals there because you have to take care of safety. So the ugly is that without any access to the vehicle, especially the hardware and also the data that is available there, deploying WordPress and maybe Doom is the only thing you can do. It's maybe fun to do, but if you really talk about automotive applications, we want to achieve more. And this is where we require the access to the vehicle hardware. Because if you look at this from a very abstract point of view, we might have sensors, like, okay, what is our current speed? And we also have actuators. For instance, hey, open the trunk, which is maybe not the typical example of your Android app here. And the reason is twofold, because, come on. The reason is that often this data is only accessible in really deeply embedded vehicle buses. So talking about CAN, Ethernet, AUTOSAR, some weird microcontrollers. So it's not like a nice and plain API that you have here. So accessing those data from the fancy IT stack is quite cumbersome and very specific to a model. And the other thing, which is also very specific to a model, is how do we actually express this data? For instance, again, the vehicle speed. In one model, it might be just a random bit sequence on the canvas. In another model, it might be a specific frame, but it's always different depending on the year, the model, the variation, the brand. So there's not much of standardization going on in here or happening. So to visualize this problem, we end up in a really high end-to-end complexity. And this is also which makes it not attractive to develop applications against this, because you really end up in really, really small data silos. And you do not have any portability, you really have different changing data semantics, and it just becomes a mess, basically. So one thing computer scientists really love, and that's also not specific to automotive, is abstraction. So you will see a lot of abstraction layers in all over computer science, so also in automotive. And this is also what I argue here, because I think it makes a lot of sense to have a sane and common idea of such a vehicle abstraction. To first realize scalability, but also portability. So it's easier to maintain those apps. It's also more attractive to develop against these applications. So a couple of hours before, there was on the same stage another talk saying, okay, the user base for some of the OEM brands is very small compared to the user base of a regular smartphone. So you have to find ways to make it more attractive to develop against this, also against vehicles. So this is a challenge that we have here. And the solution is already given in the title, because the solution is something that we developed in an organization called Covisa. And this is an alliance for connected vehicles with some tier 1s, some OEMs. And it initially focused on, hey, how do we get Linux up and running in a car, especially for in-vehicle infotainment? And from there, it evolved and evolved. So there's a sub-branch for Android now. And there are also a lot of people talking about exactly this abstraction. And this is the Vehicle Signal Specification, VSS. So what ESS essentially does, it's twofold. So you have a taxonomy of data structured in a tree, So for instance, here, if you have vehicle, cabin, seat is belted, you can figure out whether the person sitting in the seat is wearing a belt. Quite straightforward. But the other thing is also it defines a rule set. So with this rule set, you can define your very own tree. So you could start up a tree for two-wheelers or maybe for trucks. Or you can also change the default tree, which is already standardized, and make your own tree based on that. For instance, we had some use cases around fleet management where we were not talking about regular vehicles, but actual trucks. And a truck does not have 2 axles. It has 6 wheels, maybe 8 wheels. So we could just easily extend the VSS data model to reflect those changes to the specific vehicle. So to give you some examples how this actually looks like, it's very influenced by the YAML notation. So you have the idea, okay, we have some sensors. So here we can only read this data. So for instance, the vehicle speed would be such an example. You could add also the unit, like in this case, kilometer per hour. It's not miles per hour, which could be a huge problem if you want to work against this abstraction, and you have this description. So instead of having the pure data, you actually get some semantics on top. The same with actuators. For instance, you have a signal called horn is active. You know it's an actuator, so you can also interact with the signal. And since it's a tree, we also need branches. So that's why you have sensors and actuators which can belong to a branch, like in this case, the vehicle identification VIN, which is an attribute which won't change over the course, at least of one ignition cycle. So with these very basic blocks, it's already possible to structure your data that you have in the car, again, to come to this VSS tree. If you ask yourself now, okay, is this relevant or is it just a random dude on a stage talking about these things? Actually, it's an open source project with a number of companies involved, like Bosch, the company I work for, ETES is involved, Renesas. BMW is talking a lot about using and also extending VSS also for transporting data. And there's a small cloud company called AWS, which adopted this in the IoT Fleetwise product. And maybe soon, one of you guys will also join in. That's at least the intention of why I'm standing here. If you're more interested in figuring out, okay, this VSS sounds cool, but I'm not a big fan of reading YAML files for hours, you can also go to a website called Digital Auto. And here in Digital Auto, you get an idea of the VSS catalogs, so the different signals that are available. And you will also see that there are different models, or for different, let's call it, versions of this model, which also explains that there's not the one and single VSS, but also the way to flexibly extend it the way you want it or need it in your specific vehicle or use case. Okay. Now, I know this is an Android conference. I managed to talk about for maybe 6 minutes without saying the word Android. And people that know the Android automotive ecosystem will say, wait, what he's telling about, this sounds like VR to me. So what's the point here? It's right, but I would say that VSS has a bit more holistic view on the whole vehicle. So there are way more signals, first and foremost. Don't quote me on the numbers, it's just a raw estimate in both cases. And but more domains that you can look into. For instance, for VSS, you also get signals from the OBD port or from the powertrain, or also a bit more about information about the driver. And as I mentioned before, VSS is not just one single set of signals, it's also the way that you can extend these signals or create your own tree with the same rule set. So that's nice, we have a data model, but if you really want to deploy this stuff, how do I actually manage my signals in a car? And the answer, I mean, that's what I'm here for, is this. Quick question. Are there any Finnish people in the room? Okay, so you might be the one getting this pun, because Kuxa is the product that I will talk about in the next minutes. And Kuxa initially stands for this drinking cup. So that's maybe something you can remember. Kuxa, drinking cup, vehicle abstraction. I know it's a long chain, but that's where it's coming from. And you can also see there's a sneak peek into Android being into Kuxa. Because what is Kuxa more on a technical level? It's first and foremost something that we call a data broker. So a VSS data broker, it's a bit like an MQTT, but it's really tailored towards VSS. You can load a VSS model into that and then use the same gRPC-based API to interact with these signals. And this way you kind of create an in-vehicle digital twin based on VSS. So you use this API and you get the current status of the vehicle. And current, I really mean current, because there's no historic data, also because we wanted to make the data broker as small and simple as possible, and also specific to the automotive requirements. Part of this is also that the reason why it's written in Rust, and it's also a 100% open source project available under the Apache 2.0 license, developed under the umbrella or the helm of the Eclipse SDV working group. So there's a whole working group in the Eclipse Foundation dealing with the software-defined vehicle, and Cuxa is part of this. So what is this on the architectural side? I already talked about the data broker, but we also have applications that consume the data from the data broker and make use of the fact that the data is available in VSS. But now you ask, of course, okay, if the data is available in VSS, where it's coming from? Because we still have this really complex variation of different vehicles, models, communication technologies. And this is where providers come into play. Because this concept of a provider is exactly there to convert between non-VSS data and the VSS data in the data broker. And this is also what's happening in the next slide of the battery would work. Because kind of the same picture, just a bit different. Again, we have our very deeply embedded layers on the bottom, and then the provider converting to VSS, or the vehicle signal specification, and then any kind of application can consume this data. Could be an Android app, could be another application in the vehicle, or also maybe a way to transfer this into the cloud. And this is also where this pyramid might help in the understanding, because in the lower level, we really talk about data. So if you, as a human, look into what's happening here with these microcontrollers, you often have no clue what's going on, because it's just sequences of bits. By associating these bits with the semantics defined in the VSS data model, we actually can create some information out of that. And in the next layer, or next step, you would be able to apply some reasoning on top of these VSS signals and create some knowledge. And this is also an application where some OEMs are looking into currently to use VSS on this more knowledge graph side in the backend. Coming into an example, how would an actuation with the data broker look like? So your app, for instance an Android app, would like to open the trunk or initiate the opening of a trunk. So what it can do is can set the target value for your signal, because this is a really important concept. The data broker has a target value and a current value for each of these signals. So you would set the target value, initially saying, hey, my beloved car, please open the trunk. And then you have something that we call a trunk activation provider, which is already implemented and provided by the OEM, which listens to these changes to the signals and then interacts with the EE network, so CAN, SUMIP, DDS, whatever you like, to actually perform this activation. And then the trunk opens, or maybe not. In any case, there's a data provider which does the way in the opposite direction. So this would listen to the E network and then figure out what is the current state. So the current value of this signal. So again, our vehicle body trunk rear is open VSS signal, and transfer this back to the data broker, and then the application can subscribe to this current value and see, okay, the trunk has opened now. And if the trunk is not opening, it could be to the application to react to this, maybe try to set the target again, or show error message to the user or something in this regard. So this is kind of how you do the activation with the data broker, because you have the target value and the current value for the signal. Since we are in automotive, and we definitely have to get safety and security right. I mean, I don't want to talk about all the horror scenarios that can happen, but that's something you have to really take care of. And I won't go into a whole safety assessment of the data broker or the whole architecture. I think this is specific to your architecture and the vehicle that you work on. But the general idea is that when it comes to safety, and that's where we have these nice helmets, it's more something that would happen in the providers. So we encapsulate this functionality into the providers, because they then have to ensure that the system is still staying in a safe state. So for instance, if you set the target value for the trunk to open and your car is moving with 150 kilometers on the autobahn or the highway, the provider should maybe not do this. But at the same time, you also want to get security right, and this is where the data broker helps you, because it also ensures that you can or have to use valid JWT tokens to change signals in the data broker. Okay. So far, I only talked about these providers as more like something, okay, this is around and the OEM will bring this to you. But since I'm talking about open source technologies, there are, of course, also a lot of providers available in open source. In the Cuxa project for CAN, you can replay CSV recordings, so you're not relying on any mock from a specific vendor or something. You can just replay the CSV into the data broker, or also for some IP, or there's a mock provider. In case you're wondering what this guy is doing here, I have no clue either, because I had no idea how to visualize a provider, and I wanted to give you a visual representation of a provider, so I just put it into DALI, and at least that's what the AI thinks what the provider is. So think of it like this. With this established, we know what Cuxa is. So we kind of know there's an abstraction inside the vehicle, which would sit below an Android application, and we also have established a bit how this abstraction interacts with the vehicle below. But I already see some people leaving because maybe not too much Android content. So what is Android doing here? And the answer is fairly easy, because we also developed an SDK for this. So in case you do not want to rely on the VHAL or find a lot of VSS signals which are not available maybe in VHAL, but in VSS, you could think of using the data broker and then interacting with it from your Android SDK through this application through this SDK. And it's fairly simple. So here we first have to connect to the data broker using this managed channel builder, because in the end it's a gRPC connection. And once we have this connection, we can do some cool things like fetch. So the fetch, also you just put a string in there with the vehicle signal. So in this case, we would fetch the vehicle speed. And we also give the field value. So we tell the data broker, hey, now I'm interested in the current value. You could do the same with the target value and know, for instance, okay, my trunk should be open, and then you check the current value to see whether it is open. For speed, this won't work because speed is just a sensor, so you don't have a target value. Which is maybe even more interesting, especially for use cases like speed. You can also subscribe to it. So whenever the value changes, you can register or define this callback on entry changed and get the updated vehicle speed values in this example or for any other case. This is basically the main interaction that you have with the data broker: get, subscribe, and I haven't talked about set yet, but it would be quite similar to get. If you developed a lot of apps like this, you might already notice a problem, otherwise I tell you, because we have with giving the vehicle speed as a string here, one source of error is you just put vehicle speeds or speedo or some other typo, and this is not available in the data model. And this would compile fine, because, I mean, how should the compiler know that this signal is not existing? But it would raise an error or an issue with your users, which you don't want to. Because of that, it's also possible to take your VSS model, which you can also define yourself based on this whole rule set, and then create a Kotlin data class out of that, and basically have the domain model based on the VSS model. And this makes development then way easier, because here we do the same thing. We fetch our vehicle speed, and instead of really writing vehicle.speed, we can use this VSS vehicle.VSS speed and do the same thing under the hood. For subscribe, it also looks similar. We again can do VSS vehicle, VSS speed, and now use the VSS node subscribe request for the VSS speed, and then some more code to react on any of these changes or when the subscription has been triggered. Okay, so if this sounds interesting, or if you're not convinced yet, there's also an example application, which is a really good starting point to get used or started with this in development. So you can look into how this companion app has been developed. So it has some basic functionality an OEM would put in their app. like, okay, how do I open and close my doors, or also interact with the lights to maybe make a vehicle sequence or welcome sequence, if you have the permissions to do so. But this is still a really basic interaction, because you can maybe open or close the door, but what is more complex is something like this. So the question is, can everything be a signal? So otherwise you might end up in a situation like this poor fellow, because you want to move a seat, which sounds fairly easy. Just to tilt, position, H, and then seat will magically move to that position. But in this whole signal-based approach, you would set vehicle cabin seat row 1 driver side tilt to the right position, then you would set vehicle cabin seat row 1 driver side position to the right position, and last but not least, vehicle cabin seat row 1 driver seat height to the right position. In the meantime, you already killed or destroyed the legs of the person sitting on the seat, because maybe you should adjust the height before you adjust the position. So these can be some constraints that you run into when you really work on the signal base. So some people might argue, okay, that's something that you have to take care of in your application, because that's what the signals are for. Other people say, okay, we want to have a further level of abstraction, not just the signal, but also more some kind of services, which will then take care of this. So that's where another project is coming into play, which is getting more traction also around Android. It's the so-called Covisa use services. Because here, in the Covisa use services, it's something that GM more or less recently published also to the Covisa ecosystem. It's a set of services that you can find in a vehicle. For instance, seating, again, would have this move seats, which looks a bit different in the meme that I just showed before, but it's essentially quite similar. You also have set seat temperature or set seat massage, and then it's up to the implementer of this seat, or again of the OEM, how to realize this service or this function, but it's a bit more abstract than really figuring out the right signals and working on the right abstraction here. A more easy example is horn. So, I mean, for horn, what could the service be like? Yeah, activate the horn or deactivate the horn. Fairly straightforward. But even here you have more abstraction compared to the VSS signals, because in the activate horn you can define a whole sequence for turning on and off the horn, where if you interact with the signal, you would only be able to make it on or off. And this is also, yes, I'm missing something. The orders, okay, here we go. And this is also something where you could put all of these things together, because you could implement the service for this horn. And this service under the hood could still use a data broker. You could find very other ways. You could directly interact with your vehicle bus, or it could use the data broker here and then change the signals there. And then the data broker would have a provider which interacts with the actual horn, which might be, I've drawn an API interface here, but maybe this API interface is simply a wire, where you just put some current on or not to turn on the horn. But even if we have the service now, which is available, how do we find the service? Like, how do we interconnect this thing? Because the situation in the car might often look a bit like this. Sorry, it's again AI generated, so good luck finding any plug which is an actual plug. But that's another story. How do we interconnect these? So we might have an Android system, we might have some gRPC, we might have some SAMIP, we might have some CAN. Don't have to know all these technologies, but it's getting complex pretty easily. And this is where another project that GM started and other companies in Covisa are picking up this. It's the so-called Eclipse U protocol. Because with the Eclipse U protocol, what's happening is you again look into these three layers of such a service exchange, being the application, the communication, and the transport and session layer. And this is also already by the naming, you can guess that there's a connection between U protocol and U services, because it's not a coincidence that the U services are defined in Proto. Because in your protocol, again, the idea is to have a protobuf definition of your service payloads, and which you can serialize and deserialize to protobuf, together with your protocol-specific header. And this combination then allows to transfer the your protocol data with the payload over different transports. Because the main aim of this whole open source project is to, or not the main, but one of the major aims, is to have the transport and session implementation for different transports. So you could have your Android binding from an Android application, which is then sent over your protocol to a service which is actually implemented at some IP. And then it's transparent to the application that the implementation side is writing using another communication technology. So, which could also be MQTT. And this brings us back to this picture that I just shown, because again, we have our implementation, which could be, for instance, over Zeno, which is another communication technology which you don't have to care about if you're in the Android domain, because here you can use the Android U transport, and then the U protocol will transfer this whole communication exchange towards Zeno, and then the service can be consumed using this communication technology, which is quite the beauty of the U protocol here. This is a slide I just put it into to show it's not as easy as on the previous picture. There's a bit more to it. So many of these boxes are developed in the EU protocol ecosystem. So for instance, you have the streamer if you want to transfer data between different devices, or you have some services for discovery or subscription to manage subscriptions and discovery of service exchanges, or also some U apps. You might say, especially if you're a bit more, sorry to say, a bit seasoned more developer, I talked to also other senior colleagues that said, I've seen this and it looks like an enterprise service bus from the 2000s. You're not completely wrong, I would say, but the caveat here is that it's really specific also to the protocols and the architectures that you currently see in automotive. And that's also why I put it into this talk, because again, you have the whole transport or communication enabled from your Android application into the really deeply embedded layers of the vehicle through the means of the U transport and the U protocol. So with that, what did we achieve? So our aim, or at least my aim was to show you how you can enable the SDV for Android, or also how you can interact with the SDV and the open source technologies in the SDV from an Android application. So what were our problems? So first and foremost, we started by that the semantics and the representation of the signals are not similar across the vehicles and OEMs. So they are different vehicles. So here, Cuxaval leveraged the standard Covisa VSS. So Covisa VSS helps us to get some more abstraction and standardization going on here. But also, signals often might be limited to specific domains and not very flexible. So you run into problems if you run specific signals from a specific OEM, because then you have to work on the whole stack from that OEM potentially. While with VSS, you can simply extend your default tree and work with that even with this extension, because the tooling still works. Another big topic is, and this is also a thing where becomes very complicated to enable these Android apps, is letting any application, not just an Android app, access lower level vehicle systems is simply almost insane, or it's insane, sorry. So it's something that should not be done, that you can just let a third-party developer access, let's say, the trunk or some other vehicle systems. So here, Cuxaval is a really good control point to do this, and also the architecture around with the providers below and the permissions that you can set in the data broker allows you to have some safety and security control points. And last but not least, many operations, like think of our seed, might be too complex or maybe just too specific. So maybe just Conway's law is kicking in here to have a common abstraction that you would get through signals, where you just do get and set on a signal and then achieve something. So here, the U protocol can help you a lot, and also the U services, because they already start to define how a service like this could look like. Here we go. And so with that, I hope you got a bit out of this talk and seeing, okay, where's also the Eclipse SDV ecosystem and also, the Covisa ecosystem going into, and also you have a couple of links where you can maybe follow up if you're interested in one or the other projects. Otherwise, thank you very much for being here, and I'm happy for any conversation, especially also why you think this is maybe a very bad idea, because that's also what we're looking for when developing those things, why people don't use the technology. So thank you, and happy for any question.